Hello everyone, today we're going to be going over some sample math questions from the 9th grade SHSAT. These questions are from the 2023 SHSAT Student Handbook, which is made by the Department of Education that makes this test. So for anyone who's taking the 9th grade test out there and you are in need for more preparation, or you don't know what the 9th grade math section will look like, these sample questions are supposed to simulate that. It's not the full test, but they give you some questions so you could test the waters. And if you're doing well with these, you'll probably do well on the test. So we're going to start off with number 1, which says 0.44 is equal to x over 25. What's the value of x in the equation? So for this one, they're asking you to solve for x. How do we solve for x when we have a fraction? We just multiply both sides by the denominator. So in this case, we have to multiply both sides by 25 over 1 to isolate x, right? So we multiply both sides by 25 over 1, and we get that 25 times 0.44 is equal to x, right? And just to make my math easier, instead of just calculating this on here, that's going to take a while, I'm going to convert 0.44 into 44 over 100, and then I'm going to multiply that by 25. And the reason why I'm doing this is because this is a lot easier to do. Why is it a lot easier to do? Because I noticed that here I have a 25 in this numerator, and I noticed that 100 is divisible by 25. So I can take away this 25. I can divide this numerator by 25, and I can divide this denominator by 25. And essentially what that does is it turns this long math problem into 1 over 1 times 44 over 4. So whenever you're dealing with multiplication with fractions, always try and reduce the terms on both sides. Here I reduce the terms in my numerator and my denominator because I noticed that my numerator on this side and my denominator on this side are divisible by one another, right? So in this case, I took out 25 from my numerator, I took out 25 from my denominator, I'm left with 44 over 4, that's 11, right? And that's a lot easier than doing 25 times 44 and then moving 2 decimal places to the left, right? So just remember that whenever you have a x or a variable that's being divided by a number, the way to get that variable on its own is to multiply that variable by whatever's in the denominator. So in this case, we have x over 25. In order to get rid of that x, we multiply by 25 over 1. Or we take our denominator, we put it in a numerator over 1, and we multiply it. So number 2 says two equations, y equals 6x minus 5 and y equals negative 3x plus 7 are represented as lines on a graph. What is the y value of the point of intersection between the two lines? So what's happening here? What's happening here is that we have a graph, right? We'll use the coordinate plane right here. And we have 6x minus 5, which looks something like this. And we have negative 3x plus 7, which looks something like this, right? And you can see that these two lines are going to intersect, and they're going to cross one another, right? Intersection just means when the two lines cross. And it's asking you, what's the y value of the point of intersection? So number 1, we have to find this point right here. And from that point, which is going to be in x comma y, we need to find the y value of that point. So it's handy to know what exactly happens when two lines intersect. When two lines intersect, they have the same x value, and they have the same y value. In other terms, the two lines are equal at that point. They have the same x value and they have the same y value because they're in the same place. Your x and your y tell you what position a point is on the graph. When two lines intersect, they're at the same place. They're at the same position. If you're walking this way and your friend is walking that way and you two bump into one another, that means you're in the same place at the same time. Which means, if we just apply that to lines, that means that in order for two lines to intersect, they need to be at the same place at the same time. Meaning that they need to have the same x value and the same y value. So that's what we're solving for here. We're solving for our x and our y value. How can we do that? Well, we can do that by making the equations equal to one another. Notice how both of these are in terms of y. Y is equal to 6x minus 5, and y is equal to negative 3x plus 7. Because they're both equal to y, I can set them equal to one another. 6x minus 5 is equal to negative 3x plus 7. This y and this y means that I can take this and set it equal to this, because they're both equal to the same y. That makes sense. And now all you have to do is just solve for x. How do you solve for x? Well, you combine like terms. So you add 3x on both sides. You're left with 9x minus 5 is equal to 7, and you add 5 on both sides, and you get 7 plus 5 is equal to 12, right? So you combine like terms and you move everything to one side. You get 9x is equal to 12. If you divide both sides by 9, you get that x is equal to 12 over 9, or 4 over 3, so 4/3. But 4/3 isn't our answer, right? 4/3 is only part of our answer. Why? Because this is the x value at which they intersect. If we go ahead, we draw a coordinate plane again, we know that at this point where they intersect, our x is equal to 4 over 3, or this point is 4/3. Now we need to find our y value. They're asking us for our y value. And look, this is literally telling us what y equals when x is something. right? All of these equations literally tell us our y value based on an x value. We just solved for an x value. So all we have to do is just plug in that x value into either one of these equations. So I'm going to plug it into this one. If y is equal to negative 3x plus 7, and my x is equal to 4/3, that's the same thing as saying y is equal to negative 3 times 4 over 3 plus 7, right? This cancels out, this cancels out. I can take a 3 away from both of these, so I'm left with negative 1 times 4, which is negative 4, and that's being added to 7, right? So negative 4 plus 7 is equal to 3, so my y is equal to 3, which is the y value of the point of intersection. So here, y is equal to 3, and that's going to be my answer, right? So just remember that whenever you want to find the point of intersection between two lines, and they give you the equation of those two lines, set them equal to one another. Set them equal to one another. When you set them equal to one another, it's going to give you the x value of their intersection, and you can just plug that x value in for one of the equations that were already given to you, and that's how you solve that. Number 3 says the function 2x minus 4 is graphed. The line of the graph travels to the point 0, negative 4, and the point 12, y. What is the value of y in the point 12, y? So for this one, you need to know how points are organized and how we kind of denote points on a graph. We denote them, or we represent a point on a graph by writing it like this, x, y. So if I wanted to plot a point, say this point, and here's 2 and here's 1, this is actually the point 2, 1, because we take the x value of that point, which is 2, and then the y value of that point, which is 1, right? So the coordinate point here is 2, 1. Now they're telling you that on this same graph, you have this line, and I'll draw it out, right? 2x minus 4 looks something like this. And they're asking you, when x is equal to 12, what is the value of y on this position, right? When x is equal to 12, and we draw, so x is equal to 12 is going to be this line right here. We draw it up, and then we see where it intersects this line. It intersects this line at this point. But now they're asking, what is the y value at that point? How can we solve that? Well, we can solve that by just plugging it into our equation, the exact same thing we did in our last problem. Remember how this gives you every single point on the line based on the x value. So if y is equal to 2x minus 4, and my x is 12, plug in 12. So now y is equal to 2 times 12, which is just 24. So we go ahead, we say 24 minus 4. 24 minus 4 is 20. So y has to equal to 20. That's our answer. Number 4 says, which number has a value that is located between 7 and 8 on a number line? Okay, so what's happening here? So a number line is just a line that has a bunch of numbers on it that's organized from least, from least to greatest, right? And it goes on forever. So let me just draw a number line for you. Here we can have the point 0, here we can have the point 7, and here we can have the point 8, right? That's going to be our number line. Now they're asking you which 2 points lie between 7 and 8 on a number line. And in other words, which one of these values is greater than 7 but less than 8? In other words, which one is going to fit in between 7 and 8? And they specifically gave you answer choices that you can't compute, right? You don't have a calculator on the HSAT, so you can't necessarily figure these out just by looking at them. You don't know what radical 37, radical 47, radical 57, or radical 67 is because they're not perfect squares. What you do know is that you can get rid of this radical sign if you just square it. Whenever you take the square of a square root, if you square a square root, it's a lot of squares, but say I have like 13, radical 13, or the square root of 13. If I square this, I get 13. And that sign gets canceled out, right? So the only way that we can really interpret this or get value out of these numbers is by squaring them. So I'm going to do that to each one of them. And I get 37, I get 47, I get 57, and I get 67. That looks really bad, but you know, we're good. So now that I squared these values, none of them go between 7 and 8. But that's because I didn't square 7 and 8 as well, right? The reason why I'm squaring everything in this problem is that so I can actually understand what these numbers mean. I don't know what radical 47 is. I know that radical 47 squared is 47, right? So by squaring these answer choices, I am understanding the numbers. But because I squared my answer choices, I also need to square every other number here. I need to square 7 and 8. And when I square 7 and 8, I'm left with 49 and 64. So now, because I squared everything, which number falls between 49 and 64? It has to be 57, right? 57 is in between 49 and 64, right? And now look what I can do. If I just take the square root of all of these numbers, look what happens. Instead of, I'm now keeping these numbers in this same order, right? But I'm taking the square root of them. And what happens is that the square root of 49 is 7, and the square root of 64 is 8. I don't know what the square root of 57 is, but I know that it is between 7 and 8, because when I take the square root of everything else, it still lies between 7 and 8. Right? So the method for this problem would be to square every single answer choice so that you can get it into a whole number form. And then you also square the two numbers that you're trying to find is between them, right? So you square 7 and you square 8, and you see which one of these numbers squared falls between them. Right, so number 5 says, in the figure above, line K is parallel to line M. Whenever you see these two lines between two letters, that means that this line is parallel to this line. What do parallel lines mean? It just means they never touch. They never intersect, right? They go on next to one another forever, but they don't touch. Kind of like a railroad beams, right? Or rails, I guess. In the figure above, they're parallel. Straight line P intersects both line K and line M. The measure of angle T is 47. What is the measure of angle J? This is a formula, not a formula, but a rule that you need to figure out on the SHSAT. Whenever you have kind of this situation, right, where you have two parallel lines and something is intersecting them, there's a special relationship between the angles. It says that this angle and this angle are going to be equal to one another. This angle and this angle are going to equal to one another, right? So everything that's in blue equals one another, is equal to each other, right? Everything in red, on the other hand, is also equal to everything else in red, right? So you just need to figure out that this is the relationship between the angles on two parallel lines and a line intersecting them, right? The blue is always going to equal one another, and the red is always going to equal one another. Now, if you look here, the point J is in red, right? And I just drew another red angle right here, which means that this also has to be angle J, the same way that this is angle J, and the same way that this is angle T, and that this is angle T, and that this is angle T, right? If you just know this form when it comes to angles, you can rewrite this top one with the variables that were already given to you, right? So this is called something called vertical angles. You should know this for the test. If you just remember that, you'll be good, right? So all I did here was I remembered that formula, and I recognized that this angle right here is going to equal to J as well, right? So I know that T is equal to 47 degrees, and I know that J is here, and I know that T plus J has to equal to 180 degrees because they lie on a flat line, right? This is a flat line, which means that the angle, the measure of a flat line is 180 degrees. So when you add T, which is equal to 47 degrees, plus J, you get 180 degrees. So what you need to do is you need to do 180 minus 47 to get the value of J, which is 133 degrees. Number 6 asks us which of these numbers is irrational, right? So what is an irrational number? An irrational number is a number with a non-terminating and non-repeating decimal. And I apologize for the construction that's going outside. So non-terminating and non-repeating decimal. The number 2.5 has a terminating decimal, right? Non-terminating means it goes on forever, right? 2.5 ends right here, so it is terminating. But if I had the number 2.5555555 going on forever, that would be non-terminating, right? And in addition to being non-terminating, it also has to be non-repeating, right? So actually, 2.55555 infinitely is rational because it repeats. The 5 just repeats forever and ever and ever. So because it is repeating, it is rational, right? But an irrational number has a non-repeating decimal. And what that means is pi is irrational, right? Why is pi irrational? Because pi is equal to 3.1415192, and it goes on forever, right? It goes on forever, so it's non-terminating. And it also doesn't follow a pattern, right? Every other number here is going to be different. It's not going to repeat. You don't know that every number after this is going to be 2, 2, 2, 2, 2, 2. You don't know that, right? So it's something that goes on forever without any pattern. And that also kind of applies to any non-perfect squares. So radical 4 is rational because that's equal to 2. But radical 5 is irrational because when you take the square root of a non-perfect square, oftentimes, if not most times, you are left with an irrational number, right? So just following that rule, that the square root of a non-perfect square is going to be irrational, choice H is correct. Choice E is incorrect because that is rational. Remember, this bar above a decimal means that that number repeats forever. Notice how I said repeats. So because this is a repeating decimal, that cannot be irrational. Radical 9 is a perfect square. That's 3. 9 over 7, this is rational because it can be expressed as a fraction. Pi cannot be expressed as a fraction, right? Without using pi to represent it. So number 7 says triangles JKL and J prime K prime L prime are congruent triangles. What does congruent mean? It means it's the same, right? These two triangles have the same area. The distance from J to K is the same as the distance from J to K here, right? It's the same triangle, they're just oriented differently. And they're asking which two transformations were used to transform JKL into J prime K prime L prime. So what are the transformations? Well, when we have transformations, we can have reflections, okay? We can have translations, and we can have rotations, right? So what is a reflection? A reflection is over an axis, right? So it can be over the x-axis or it could be over the y-axis. And what it does is it moves the shape from one axis to another. And it kind of mirrors it over an axis, right? Imagine that these two sides, side 1 and side 2, are pages on a book, right? Whenever you reflect something across the y-axis, imagine that you're flipping up this page onto this page, right? You're just flipping it. So if I were to reflect this across the y-axis, this would be point J, this would be point L, and this would be point K, right? And I'd have a mirror image on the other side. So just imagine that you're taking this whole page and you're flipping it, and then you're drawing what you see on this side, right? So that is what a reflection is. You can also have a reflection over the x-axis, right? And it's the same thing. Just imagine that this is page 1, that this is page 2, and you're just flipping this page downwards. So you'd have something that looks like this, right? Where this is K, J, and L. Something like that, right? So you're kind of flipping a page. When it comes to translations, translations means that you're just moving a shape in a specific direction, either up, down, left, or right. So if I were to translate this 3 units to the right, that means that this point J would be here, point K would be here, and point L would be here. So rather than flipping it or flipping a page, you're literally just moving the object from page 1 to page 2, right? By a set amount of units. Translations always have translated up by 3 units, translate down by 3 units, left by 3 units, right by 3 units, right? And finally, we have rotations. And when you rotate a point, you're just moving it by a certain amount of degrees. So if I were to rotate this triangle, let's say clockwise by 90 degrees, this point, I'm literally just spinning this around itself, right? Or I'm just spinning it. So if I spin it by 90 degrees, point K ends up here, point L ends up here, and point J ends up here. And look, I am now oriented in a different position. So those are the 3 different kinds of changes that you can do to a shape, right, on a set of axes. And now it's asking you, how do we get from this shape over here to this shape over here? Choice A says a reflection to the right, and then a reflection across the y-axis. Well, notice here how when we reflect something, the position of the points are usually preserved. What I mean by that is if I were to translate this to the right, by how many units, right? If I translate this all the way to the right, then I end up like over here with point K right here, point L right here, and point J right here, right? And then if I translate that, if I reflect that across the y-axis, I end up back here, right? Which is not how we end up on this side of the page. Otherwise, if I were to just reflect this, right? Notice how I'm still in the wrong position. My points here, this would be my point J. This would be K, this would be L, and this would be K. I need to rotate the shape in order for it to be oriented in the right position, right? So this is false. A reflection across the x-axis, this choice is also wrong because guess what? My shape that I need to get is on this side. It's on the other side of the y-axis. If I were to reflect this shape over the x-axis, my shape would end up here, which is nowhere near my reflected shape. A rotation of 100 degrees about the origin and a translation across the x-axis. This is wrong again because guess what? I need a translation across the y-axis to get to the other side, right? But if I had translation around the x-axis, I end up down here again, which is not where I need to go. So that leaves us with D as the correct answer choice, and I'll explain that as well. Choice D says a reflection across the y-axis. So guess what? We flip the page over here. So here we have J, here we have L, and here we have K. So now we have this brand new triangle. And now notice how even though we're on the right side, we still need to move around these points, right? We need to orient it and spin it in the right direction. And here they say a counterclockwise rotation of 90 degrees about its center. So you know that a regular clock spins in this direction. A counterclockwise would then spin in this direction, right? So think about it. If I just spin this entire shape like this, if I move L over here, J over here, K over here, we get the shape, right? We get it in the right place. So then we have to rotate it. That's why. Number 8 says the scatter plot shows a set of data. Which equation represents the most accurate line of best fit for the data? So what is a line of best fit? A line of best fit is a kind of something you use in statistics to show a relationship, right? It's to take a bunch of points on a graph and kind of fit them to a line, aka the line of best fit. And the general rule for a line of best fit is you want as many an equal amount of points above the line and below the line. So if I were to draw a good line of best fit, I draw it something like this. This would be a good line of best fit for the data because you have 1, 2, 3, 4, 5 points on top and 1, 2, 3, 4, 4 points on bottom, which is a pretty good amount. And you even pass through 1. So number 1, you want to have the same amount of points above it and below it. And number 2, you want to be pretty close to the points, right? Your line shouldn't be all the way on the other side of the page, right? You should be in between your points. You should pass through some if you can. And you should have the same amount up top and below, right? So automatically I can eliminate choices E and choices G because they have negative X. Why can't I have negative X? Because negative X looks something like this. This has all the points on one side of the graph, right? There's no points on this side of the line, right? Which means that it's a bad line of best fit because it doesn't capture the same amount of points on both sides. The same thing goes for negative X plus 2. That just means it looks something like this. You have negative X and then you move it 2 units up. Once again, all my points are on one side and not the other. And that leaves us also with choice H being wrong because look, here's what y equals x looks like. This line that I already drew, albeit incorrectly right now, sorry. This line is going to look something like this. And it's also going to extend downwards. We already said that there's 5 points above and 1, 2, 3, 4, 5 points below, right? So this is an equal 5 above, 5 below. This is a good line of best fit, right? It captures the same amount of points above it as it does below it. But if I have x plus 2, y equals x plus 2, that's the same thing as saying y equals x, but just 2 units higher. And when I draw that out, look what happens. All my points are below the line, which means it's a bad line of best fit because I don't have the same amount of points up top and below. So then number 9 says, what is the point of intersection between the graphs of y equals negative 4x plus 3 and y equals 2x plus 5? We've been over this already. We had a problem that asked us about the point of intersection before. All you need to do is just set these graphs equal to each other, right? So all you have to do is just say that negative 4x plus 3 is equal to 2x plus 5. And you just combine like terms. So you add 4x on both sides. You're left with 3 is equal to 2x, nope, 6x actually. So 6x plus 5. And you subtract 3 on both sides, and you get that 0 is equal to 6x plus 2. And then you subtract 2 on both sides. I guess I'm doing this a little bit slowly. You have negative 2 is equal to 6x. Divide by 6 on both sides, and you get that negative 1/3. If you simplify 2 over 6, you get negative 1/3 is equal to x. Okay, so this is my x value, negative 1/3, right? And whenever you plot a point, remember you use x comma y. You use this format, x comma y. So here we just solved for our x, and we said our x is negative 1/3. Now I'm solving for my y. So I already know an x value. Now I need to figure out my y value, right? So all I have to do is just plug this in. I'm going to plug it into y is equal to 2x plus 5. I'm going to plug it into this right here. And I'm plugging in negative 1/3. So y is equal to negative 1/3 times 2, which is just negative 2/3 plus 5 over 1. Right, and notice how we can't just leave it like that. We need to add these two together. So we find the lowest common denominator, which is going to be 3. So we have negative 2 over 3 plus 15 over 3, which turns into 13 over 3. But notice that we need to convert this into a different form. How do we do that? How many times does 3 go into 13 fully? 4 times, right? Because 3 times 4 is 12. And 12 minus 13 is 1. So you're left with 4 with the remainder of 3, 4 and 1/3, which is going to be choice A. Moving on to number 10, it says the table below represents a linear function. The second linear function is represented by the equation y equals 4x plus 3. Which statement comparing the rates of change of the two functions is true? So right here we have a table. And this pretty much just selects some specific points from a graph, right? And then puts it on the table. So this thing has a y equals mx plus b form associated with it, but they just put it in a table and gave us 3 points. The way you read this is you look here in your x column and you know that these are going to be your x values and these are going to be your y outputs. So in this graph we have the point 12, 30, 24, 40, and 36, 50. All right, and it's asking you to compare the rates of change. So what is the rate of change? A rate of change is the slope, right? That's just another word for saying slope. And when you have a linear function, your slope is represented as the coefficient of the x, right? Or the m. So the number that's touching the x is going to be your slope. In this case, y equals 4x plus 3. This 4 is the slope. So this line has a slope of 4. Now, here we are not given a y equals mx plus b form. We need to find our slope. How do you find a slope? You find it by taking 2 points and subtracting their x's and their y's. You take y2 minus y1 and divide it by x2 minus x1. So let's do that. Let's assign some points and let's do that, right? So here I'm going to use 12, 30 and 24, 40. This is my y1, so 40 minus my y2. Sorry, this is my y2, this is my y1. So 40 is my y2, 30 is my y1. And you divide it by 24, which is my x2, minus 12, which is my x1. And you're left with 10 over 12, right? You can simplify this into 5 over 6. So we know that the slope of this line is 5 over 6. So y equals 4x plus 3, the rate of change for that, or the slope for that, it has to be greater than the slope for this, simply because it's a bigger number. So the rate of change can't be less, so E and F are out of the picture. The rate of change is greater, so F, G, and H are our candidates. And now it says the rate of change is greater because 4 is greater than 5, 6. This is true. Right, that was our slope, and that was 5 over 6. Number 11 asks, how many solutions are there to the equation the absolute value of 4x plus 6 is equal to negative 2? Now, what is an absolute value? An absolute value tells you gives you a positive value always. So if I had the absolute value of negative 2, that is always going to equal to 2. If I had the absolute value of 2, that's always going to equal to 2. Anything that's inside of these two lines, that are inside the lines of absolute value, it's always going to be a positive number. So you can never have a negative number coming from an absolute value. Notice in this equation, we have the absolute value of 4x plus 6, meaning that even if 4x is equal to like negative 2, and you have negative 8 plus 6, which is equal to negative 2, the absolute value of negative 2 is going to equal to 2. There's no way, there is absolutely no way that you could make this absolute value sign in this situation right now, in this equation, negative. This is always going to output positive solutions, which means that there's no solution to this. This doesn't exist. This is false. Whenever an equation doesn't make sense, for example, let's say that you have 5, you simplify an equation into 5 is equal to 3. This is not true, right? So you strike through that equal sign, and this means that the equation has no solution, or that the line has no solutions. Whenever you are left in an equation with something that can't be true, it means that it has no solutions. So this has no solution because an absolute value sign cannot yield a negative value. 12 says the scatter plot shows data that a researcher collected. Which statement correctly describes the data? Here we have a bunch of points that are clustered here and here. So that means that the data have clustering. That's all. If the data had a positive linear association or a negative linear association, they would be going either up like this or down like this across the entire graph, right? That would be a positive or linear. That'd be just a linear relationship would just show a bunch of points that you could draw a straight line through. If it had outliers, that means that it would still kind of follow a pattern, but you'd have like a bunch of points far away from the graph. A cluster just means a large group of points in a very small space, right? This is a cluster. In all definitions, this is a cluster, right? Because it's a large group of points in a small space. Number 13 asks us, what is the length of x in a triangle? Here, notice you have a right triangle, and you're trying to solve for the hypotenuse, or the side that is opposite the 90-degree angle. How do you do this? You remember the Pythagorean theorem, which says that a squared plus b squared is equal to c squared. In this case, our legs are a and b, so this is our a, this is our b. That just says that 8 squared plus 8 squared is equal to c squared. So 8 squared is 64, plus 64 has to equal to c squared. 64 plus 64 is 128, and that's equal to c squared. So you take the square root of both sides, and you get that radical 128 is equal to c, which is choice C. Fun. That's the last question for this section. I hope you learned something. If you have any questions, leave them in the comments below. If you want to subscribe and help me make more of these videos, or if you have any suggestions to any future topics for me to go over, 9th grade SHSAT or 8th grade SHSAT, let me know. I'll go over them. Otherwise, I hope you learned something, and I hope you have a good day.